Saxon Advanced Mathematics. Dun, 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 dun. It's lesson 100. Wow. That's an accomplishment. This is a really hard course, this Advanced Mathematics. And if you've made it to lesson 100 and are still in one piece, I'm really impressed. You're doing a fantastic job. No rest for the wicked, though. And this lesson is an identity lesson. What we're going to do is we're going to take these sum and difference identities, the ones down here that we've used, and we're going to use these, mess them around a little bit using some algebra to create more identities. And as I think I've mentioned earlier in this coursework, at first we were just memorizing different identities, but our study of this concept moves more and more toward taking the identities that we have and finding lots of different ways to rearrange them. So memorizing these becomes more important than ever because we're going to be using them more and more. All right, so I'm going to keep my list handy. Keep yours handy. If you've got your identity page, your notes, grab that and keep it close at hand. It'll help keep you on track. Example 100.1. That looks impressive, doesn't it? 100 lessons, man, that's a lot, you guys. Develop the identity for sine A cosine B, right? So we want an identity that does that. Okay, so an excellent first step, John tells us, whenever we're trying to find an identity like this, is to write down those 4 sum and difference identities. And, you know, we can do one better by just having them at the ready here. Just a second, I'm gonna grab a white piece of paper to block off the ones we don't wanna look at. We wanna look at these. All right, so we're looking for sine A cosine B. All right, and so we just scroll through our list and we see, oh, look, we've got that here and we've got that here. So if we added together these two identities rather, this part that we don't want would cancel out. That's an interesting first step. So let's go ahead and do that. I'm going to copy the sine identities onto my page. So it's sine A plus B equals, I'm just going to be quiet and let you copy these, and maybe you can do it from memory. Okay, so that's me just copying them. And now my next step is going to be to add them. I know. Who knew you could do such things, right? But you can. So what that will get me is a big fat cancel there. So then I'll have the sine of A plus B plus the sine of A minus B, right? This equals, and now we have 2 of those, 2 sine A cosine B. And the last thing, the only thing we need to do is get rid of that 2. So we can divide by 2. That'll cancel it, divide by 2. And the way we prefer to write this is 1/2 times the quantity sine of A plus B plus the sine of A minus B equals sine A cosine B. And that's what we were asked to develop, and that is indeed what we developed. And again, we used 2 of these identities that had the piece we were interested in. We added them together and did a little quick shuffle, and this is our new identity. You don't have to memorize it. You just have to remember that if you ever need that, it's a quick little exercise to do the same. Okay, what if, John asks us, let's flip the page. What if we wanted an identity for cosine A sine B? You can also write this in the other order, which I often do, potato, potato, right? So it's either one of those. Let's take a look at our problems here, our identities. All right, we're looking for this, right? The problem is that, as we just saw, if you add these two together, these are going to cancel out. So we don't want them to cancel out. So what we're going to do is multiply one of these, probably the bottom one I think I would choose. We're going to multiply it by -1. That'll turn this into a plus. Excuse me, that'll turn this into a minus. These will cancel, and we'll have something very similar to what we did in the first problem. So let's copy, let's do the sine sum identity, just the way it normally is. We just wrote this one down. I'll write it John's way for this problem, cosine A sine B. I generally like this format better. And then we're going to take the difference identity, but we're going to put a big old minus sign out in front of it. Minus, and then these will have minuses too, equals minus sine A cosine B. And we do normally have a minus here, but we're going to change that into a plus. Right? Let's just take a look at that again and make sure you understand. This becomes a minus, this becomes a minus, this becomes a plus. All right? So we flip the signs on all three terms. All right, beautiful. Now these cancel. We add them, although technically we're subtracting, but you know how that goes. We're adding a negative number. So the sine of A plus B minus the sine of A minus B equals 2 cosine A sine B. Divide by 2 to cancel that, but we like to write this as 1/2. Let me make sure I didn't mess that up at all. Beautiful. There it is. Okay. Same strategy. We just had to tinker with the signs a little bit so that we didn't end up canceling out the part we wanted. Beautiful. Can you see that since we already have these memorized, we don't want to try to memorize stuff like this, right? That'd be a nightmare. So instead, we just teach ourselves how to derive the formulas we do want, or identities, using the identities that we have memorized. Okay, and as you might have guessed, we developed an identity for this, sine A cosine B. We developed an identity for this, sine B cosine A, or cosine A sine B if you prefer. And now we're going to do this one, and then we're going to do that one. It's going to be so fun. These are called, by the way, the product identities. And I would not want you to memorize these. I would want you to just remember how to derive them. Okay, now we want the double cosine. Let's look at our page and see what we've got. Here's our different choices. We want this one, cosine A cosine B. So we're going to have to do the same as we did for the first one, where we just add them. These will cancel out and we'll be fine. So the cosine sum identity. And this is the subtraction. Okay, there's the cosine sum, and now we want the cosine difference. And that's plus sine A sine B. We add them. These cancel. It's a lot of writing, isn't it? And that equals 2 of those, 2 of what we want. We divide by 2. That cancels it, but we prefer to write this as a coefficient of 1/2. And this isn't going to fit on the same line, so I'm going to bump it onto 2 lines. Cosine of B. All right, and there's our third one. Just imagine, we're not actually using these identities for anything. We're just learning how to manipulate them. Go to a calculus or a physics class to actually put these to use in problems. What? Right? Okay, and then our last one, I think I can squeeze it right here. Now that we've got the hang of it, it's okay if we get a little crowded. This time we want sine A sine B. And I don't even need to drag my other paper over. We can see, oh look, it's right here. This is the one that we want. These naturally cancel, so we're gonna have to multiply. And I vote we change this one, we multiply this one by -1 so that this will become plus and plus, right? Technically, we could make this into -2. We could make them both minuses, and then we would have -2 and we divide by -2, but let's not do that. Let's make them positive and do it that way. So I'm gonna multiply this one by a minus sign, so that'll be minus equals, this becomes minus, and this becomes a plus. And then this one will keep the same. Oops. And this is also plus sine A sine B. We add them. These will cancel. Let's write the positive one first and then the negative one second. So we'll write cosine of A minus B minus cosine of A plus B equals 2 of these. And then once again, we just divide away our 2, but we write it as a coefficient of 1/2. My pen's running out of ink. This is a plus. Equals sine A sine B. And there it is. We used these sum and difference identities. Sorry, my ink is really starting to fade here. Okay, this is correct. That's our 4th one. So what we did was we took our sum and difference identities and we solved for each one of these products that are built into them. All right? When we solved for the first 2, we were able to just add them. When we were solving for the second 2 in each set, the signs as they exist cancel them out, so we had to change the minuses into pluses. So with the sine, we multiplied this one by -1, so we would add them both. And with cosine, we changed this one so that we were adding them all. Beautiful. All right. Now, so those are what we call product identities. Now we're going to develop some others. Again, working from our sum and difference friends, right? And these are not called product identities. These are called more sum and difference identities. And again, John cautions us, we don't want to memorize these. They're too complicated. It's much, much better if we just get a handle on how we do these manipulations, if you will, to develop them rather than memorize them as is. All right. What we're going to do is kind of weird. We're going to make an assumption. We're going to build a rule for ourselves. When we have a plus b, we're going to call that x. And when we have a minus b, we're going to call that y. All right. And then when we have a plus b equals x, and we're adding a minus b equals y. Okay, this is what we're using. But look what happens when we add them together. We get 2a equals x plus y, which we can change easily by dividing by 2. A equals x plus y over 2. All right, so here's something that we're going to hang on to. We're going to substitute these in, you'll see, all right? But we're just getting some new combinations pulled together. And then the same thing if we want to combine a and b to get two b's, it would be a plus b equals x. And then we want to multiply this one by a -1 all the way across to change the signs because we don't want our b's to cancel out. So then it would become minus a plus b equals minus y, right? I took this and I changed it all into minuses. Now when we add these, this is what cancels, and we get 2b equals x minus y. Divide away the 2, and we get b equals x minus y over 2. Sorry, this shouldn't be there, right? X minus y over 2. So look what we did. We defined a plus b as x. We defined a minus b as y. Cool. Then, manipulating that, we're able to say that a equals this thing and b equals this thing. We're going to use those in a minute to substitute into some of our identities. All right? So hold on to this. In fact, I'm going to rip this page out of my notebook so that we can refer back to this when we want to. And now let's dive into the problem. How many are there? 5, 6, 7, 8. Whew. All right. Example 100.5. Develop an identity for sine of x plus sine of y. Okay, well, we know that that x is a plus b and y is a minus b. So we're going to use that in just a minute. We know that also, we can tell just by what we're talking about here, we're going to want to use these two identities. So I'm going to copy these two onto my page. Squeezy. And then I'm going to copy the difference identity. Okay, so these are just our old friends that we've had kicking around for a couple, well, it's been a couple months now, hasn't it? And now I do the minus. All right, beautiful. So those are our tried and true identities. Now, what I'm going to do with a different color is I'm going to change, this is my other page, right? A plus B, I'm going to change that into an X. A minus B, I'm going to change that into a Y. Oh, look, sine X plus sine Y. We're getting really close to this. A, we said, is equal to X plus Y over 2. B is X minus Y over 2. So I'm going to change these as well. X plus Y over 2, X minus Y over 2. Same thing here. X plus Y over 2, X minus Y over 2. And then also here. It's getting crowded. X plus Y over 2, X minus Y over 2. Every A turns into an X plus Y over 2. Every B turns into an X minus Y over 2. Now, we're ready to add them. But look what happens. This is all canceled out, doesn't it? I could have done that before. I didn't even have to write all those X plus Y's. But it's okay. Now we're going to add this whole thing together. This has all canceled. I'll do it in green as well. So now we get sine of X plus sine of Y equals 2 sine of X plus Y over 2, right? That's these. Times, not plus, times cosine of X minus Y over 2, right? That's these two. We added them, that's why there's 2, but they are products, so that's why we multiply them. We have developed the identity that John asked us to develop. What? These are called more sum and difference identities, okay? Making these clever little adjustments to the variables, excuse me, making these clever little adjustments is what makes these problems very, very doable, right? So you have to remember these ground rules as to how we're going to change them. Okay, let's do another one. And just like last time, we just did this one, and then we're going to do the other 3. And that's what the other 3 examples are, okay? So this time, we're going to develop the identity for sine of X minus sine of Y. So this will be John says, we see that we can get this. Oh, just a second, let me write it down. What we're doing for this one is we're subtracting. So we can take these same values, but we're going to change the signs on these, right? So now we can do this mentally. We don't have to, well, I'm going to write it out again just to help you see it. Sine of A plus B. We're going to go back. I think it's a little soon to be taking mental shortcuts. So let me write it out. Oh, this is minus. Okay, but this time we're subtracting these two. So what we want to do is we want to multiply all of this by -1. So that will make this a minus, and this a plus, right? So now we see that these will cancel. And now we can do our substituting. A plus B is X, A minus B is Y. These cancel, so we don't have to worry about them. The A is X plus Y over 2. The B is X minus Y over 2. And that goes for both of these A's and both of these B's. This has all canceled. So now what we can say is the sine of X minus the sine of Y, that's this, equals, we're adding these together, 2 times the cosine of X plus Y over 2 times the sine of X minus Y over 2. Wow, that's kind of trippy, isn't it? Oh, I'm sorry, this should be, oh, I'm sorry, I'm looking at the wrong example. This is correct. I was looking at the answer to the third problem, but we're only, well, 100.7. All right. Yes, yes. Hopefully I'm not making any little mistakes in these. That's one thing I really miss about not having students live with me when I'm doing them, is that students help me catch little mistakes. Okay, 100.7. We're getting close. We're developing cosine X plus cosine Y. So we know, okay, we're switching from the top two identities, which are sine. We're going down here. We want to add them together. So let's write them out, and then we'll make the adjustments. Right? We always want to start with what we know. And then the difference identity. All right, we're developing this one, so we change this to X and we change this to Y. These are going to cancel, right? So we're not going to need these at all. And this A will be X plus Y over 2, and the B will be X minus Y over 2. It will change all of those. So now we're ready to add. We'll get cosine of X plus cosine of Y equals, there's two of these now, cosine of X plus Y over 2, and this is a product, so we multiply by cosine of X minus y over 2. Yay, that's the right answer. And then our final identity is to develop the identity for cosine of x minus cosine of y. Again, if you've got these all written out, some students can look at this and mentally go, okay, I'm gonna have to change these to negatives. How will that affect it? And you will get to that, even if you're not there now. I'm doing it the slow way because I don't wanna confuse you at this point. All right, I'm gonna start with these two again. I'm gonna write them all out. What the heck? I could take some shortcuts in this, but I don't wanna take shortcuts yet. I want you to see the step by step. I'm gonna write them first and then we'll take care of adjusting the minus signs. Yeah, that's the minus, okay. All right, now we wanna have cosine minus this, so we're gonna have to change all of these signs to minuses. That's a minus, and this becomes a minus. Okay, that means these cancel. This goes to x, this goes to y. The a goes to x plus y over 2, and the b goes to x minus y over 2. So this time, we will have, when we combine these, this one will look just a little bit different. Cosine of x minus cosine of y equals, that's all gone, and these are both minuses. That's the way it's supposed to be. That's the way it has to be. This is the only one where we end up with a minus 2 in front of it. Sine x plus y over 2 times the sine of x minus y over 2. Let me just double check. Yes, that minus sign needs to be there. Yay, we did it. We just developed 8 new super complicated identities by simply taking our sum and difference identities and rearranging them, right? This is pivotal. These assumptions that we made in order to change things here, make sure that you understand this, because this is what makes all the rest of it happen. All right, like I said, this is the real nuts and bolts of identity work in calculus and physics, is not just memorizing them, but learning how to develop them one from another. That, my friends, is the end of lesson 100. Special shout out to Kyle. Kyle, this is your last day of Saxon math because you're moving on to the good old AccuPlacer. So, let's cross off. Kyle, you will not take a final exam. The review problem that you take this week will be the last bit of testing. Hang on. My darling dog was getting into the compost bin in the sink. She can lift it out with her teeth, and it had about 100 pistachio shells in it, and I did not want her to knock those all over the floor. That would have been sad. Okay, what I was saying is, Kyle, this will be the end. You'll take your review problem at the end of this week, and then that's it. Taking the AccuPlacer, the placement exam into college, that's your true final exam for this class. There's nothing I could do that would be any more appropriate. Okay, lesson 100 is complete. Thank you, goodbye.